This section is 12.6 and we're looking at gradients, tangents and normals. Now before we get into it, I'd just like to remind you something from the coordinate geometry chapter, which is if I give you a point and a gradient, so if I say this is the point, I don't know, 2, 5, and I'll try and draw my axes, so that, there we go, there's an x-axis, there's a y-axis, so that could conceivably be about 2, 5, couldn't it? And let's say the gradient of this line is 2 as well, right? So m equals 2, and I've got a line that goes through the point 2, 5. That's enough information now to find the equation of the line. There's different ways to do it. The usual way is to use this formula, or you could use the y equals mx plus c formula, substitute in x and y and m, and then find a c. I'm not going to run through that here. That's something, I think it's chapter 5, the coordinate geometry chapter. I'm just reminding you that is a technique that we can use, the technique that we do know. If we know the gradient and we know a point, we can find the equation of the line. So, bearing that in mind, let's start looking at these questions here. Firstly, if we have a curve, a tangent to a curve, the same as a tangent to a circle, and we're used to this now from the first half of the chapter, touches the curve at one point. A normal to a curve, at that point, is at 90 degrees to the tangent, okay? 90 degrees to the tangent. So if the tangent has a gradient of m, then the normal has a gradient of -1 over m. Okay? If you weren't familiar with the normal, that's what the normal is. And now we have all the information that we need in order to be able to solve equations like this, or questions like this, sorry, example 10. So here is my curve, x cubed minus 3x squared plus 2x minus 1. And we want to know the equation of the tangent at this point on this curve. You really regularly on exam papers get variations on this question. So they might say they might just give you the x coordinate and not tell you the y coordinate. And then you need to work out the y coordinate. They might tell you to find the tangent, the normal instead of the tangent, but the technique is always the same. We know the point, we need to find the gradient, okay? If we don't know the point, then there'll be enough information in the question for us to find the point and to find the gradient. Once we know a point on the line and we know the gradient of the line, then we can use our techniques for finding the equation of the line. So, how does it work? Well, we're on a differentiation chapter and we're asking about gradients of tangents, so you might expect to find the derivative. So we differentiate here. 3x squared is the derivative of 3x, of x cubed, minus 6x for the derivative of 3x squared. 2x differentiates to 2 and 1 vanishes. So that is the gradient function. If I take an x value and I put it into here, it will tell me the gradient of the tangent to the curve for that x value. I'm interested in the gradient of the tangent to the curve when the x value is 3, okay? So I'll substitute in x equals 3, and that gives me 3 times 3 squared minus 6 times 3 plus 2, and as the book tells us, that turns out to be 11. We can work it out for ourselves. If we want 3 times 3 squared is 27, minus 6 times 3, that's minus 18, plus 2, 27, take away 18, plus 2, and we do indeed get 11, okay? So 11 is the gradient of the tangent, and we're now at the position where we want the gradient is 11, we want the line to go through the point 3, 5, and we want to find the equation of the curve. So we've finished with the chapter 12 stuff. There's no more differentiation to do, there's nothing new to do. This is a technique that we already have. Looking at it in the book, they've used y minus y1 equals m, x minus x1. They've sorted that out and rearranged it into y equals mx plus c. There we go. Looking at example 11, we're going to find the same thing, say exactly the same idea. Find the equation of the normal to the curve. There's the equation of the curve at the point when x equals 4. Okay, well, at the point when x equals 4, they've not given us the point. In example 10, they gave us the point. At this point, they've only given us the x coordinate. How do we find the x coordinate? Well, the point that we're talking about is on this curve. So if I want to find the y coordinate equals 8 minus 3 times square root of the x coordinate. Okay, just substitute the 4 into the equation. So y equals 8 minus 12, so y equals minus 4. No, it doesn't. I've made a mistake there, doesn't it? I'm disagreeing with the textbook at least. Give me a second. Oh dear, sorry. 3 times square root of 4, so 3 times 2. So that's a 6. That's a 2. Okay. If you're lucky, I'll have edited out that mistake, but there we go. May well still be there. So y equals 2. So I've taken the x-coordinate, I've substituted into the equation. That tells me the y-coordinate. So I'm now in a position where I know the coordinate that we're looking at is 4, 2. So find the equation of the normal at the point 4, 2. Well, the derivative we've got here, if I substitute x equals 4 into our derivative, then we get minus 3/4. So minus 3/4, and I'm just taking this look out of this blue box here, minus 3/4, that is the gradient of the tangent. So the normal has a gradient of 4 over 3. Okay, so obviously what I'm writing down here would not count as an answer. Make sure you're setting this out stage by stage if you're setting this out for an exam question. The point I'm trying to make to you is we differentiate, substitute in the x-coordinate, and that finds the gradient of the tangent. If you want the gradient of the normal, minus 1 over the gradient of the tangent. If you've got the x-coordinate, not the y-coordinate, substitute in and find the y-coordinate, then you reduce all of these questions to the point where we can cross out everything else. I want the tangent, the gradient to be that. I want it to go through this point, and I can work from there. Okay? This often causes a lot of trouble. People get really confused with these things, and the reason is because it might mix in coordinate geometry questions. They might give you the question in an unfamiliar context, but always it comes down to this idea that the gradient of the tangent is what we're trying to find first of all, and we can get the gradient of the tangent from the derivative. If we know the gradient of the tangent, that will tell us the gradient of the normal, if that's what we need. If we know the x-coordinate, we can find the y-coordinate, and then it turns into a coordinate geometry question, and quite possibly we then are expected to do other coordinate geometry things with it. So I've seen a question recently where they ask a question very like this, but they say find the point where the line crosses the x-axis. So once I've got the equation for that line, I need to put y equals 0 into that equation. People get confused because they think, oh right, there must be something else to do with the differentiation here. And actually, once you've found the gradient of the tangent at the point you're looking at, differentiation's finished, you're now doing coordinate geometry again, and you need to know your techniques from, I think it's chapter 5. Okay, that's this section.